webinar, Art Entangled. My name is Dan Kilper, and I'm the director of Connect's, the SFI Connect Center on Future Networks. And I'm also a professor at Trinity College Dublin. In this webinar, we will explore how art can influence quantum technologies and how quantum technologies might influence art, especially looking forward towards quantum internet type technologies. This is going to be a fascinating webinar where we will bring quantum experts and artists who look at the intersection between arts, science, and technology. This webinar is brought to you by our Research Center Connect, at the Center for Quantum Networks, and the Arts Formation Project. Before we get started, I just want to go over a few basics here that we do have a Q&A link at the bottom where we'd like for you to use that if you have any questions. And with that, I will introduce our panel. So the first panelist is Professor Saikat Guha. He's a professor in the College of Optical Sciences at the University of Arizona and director of the NSF Engineering Research Center for Quantum Networks. Okay, welcome, Saikat. And our next panelist is Dr. Rosemary Lee. She is an artist and researcher whose work focuses on the cultural implications of technology. So welcome, Rosemary. And our next is Dr. Tom O'Dea. He's an artist, researcher, and educator based in Dublin. His practice interrogates the political implications of different forms of knowledge and organization in contemporary society. Tom. And then we have Diogo Enrique. He is a fellow at the Faculty of Arts at Aarhus University in Denmark. He has international experience in various institutions for urban futures, digital arts and design, international networks, and human-computer interaction. Diogo. So our next panelist is Fiona Marin. She is a visual artist based in Dublin, Ireland. She's had solo exhibitions and screenings that take on topics on internet infrastructure, history, and culture. Fiona? Okay, so with that, if we can bring each of our panelists back on. So I'd like to start off this discussion by taking on this topic of sort of the quantum internet. And we have with us Saikat Guha, whose center is really focused on trying to engineer the future quantum internet. And so I wonder, Saikat, if you could tell us a little bit about your thinking of what the quantum internet will be and your perspective on the topic today.
Thank you very much, Dan, for organizing this and inviting me here. It's a real pleasure. Dan, you said I am the director of a center called the Center for Quantum Networks. Dan, if you could please confirm you can see my full screen.
Yep, we see it good, thanks.
Great, thank you. So this center is based out of University of Arizona with 10 university partners and 13 industry partners and growing, with the objective of bringing together all the technology stack necessary to upgrade the internet as we know it today to be able to carry qubits long distance. The two primary tenets that give power to quantum information processing are superposition and entanglement. The fact that a bit can stay in a superposition of the 0 and the 1 at the same time, and the fact that two parties can be correlated in a way that is far stronger than that is allowed by classical physics. It's called entanglement. Once you enable the internet to be able to carry qubits long distance and bring that service to the users through the quantum internet, it will enable a lot of different technologies, lots of different applications that is not possible with today's technology. So this center involves scientists with expertise in material science, photonic engineering, error correction theory, mathematics, physics, and computer networking. I have a few thoughts that I would like to share later in the discussion today on how art can influence quantum and how quantum can influence art. I'm really looking forward to the discussions. And if you are in the field of quantum networking and quantum information processing, we are hiring at all levels and we would love to have you join our center. Thank you.
Great, thanks, Ikat. And Rosemary, so you've been working at this kind of intersection of technology and art, and I wonder if you could talk a little bit about your background and interests here.
Yeah. Okay, I'm just sharing my screen. So as you mentioned, I'm an artist and researcher, and my work primarily the past few years has been focusing on artistic practices, working with machine learning, and grounding these in relation to the history of visual technologies. So this is just a little overview of some of my work that I did in my PhD. My most recent project has been a video work on the mythology surrounding AI, entitled Myth, Magic, and Machines. It's a collaboration with Miguel Carvalhais, and it's going to be launching next week. But just to give a quick overview of everything in such a short amount of time. In relation to quantum computing, I have immediately some initial questions, which is how could this perpetuate existing issues, because this is really common in technology. And I'm also quite interested in problematizing or challenging traditions in the way that we treat art and technology collaboration, and how we tend to view artists as either reformers, illustrators, or communicators of technology. So I'm interested in kind of approaching this as a way of thinking beyond those tendencies. So that's just a little overview of what I'm coming to the table with.
Great, thanks so much, Rosemary. So Tom, you're a visiting researcher with the Connect Center and have been working at kind of this intersection of engineering and arts and creative practice, social issues. You want to give us kind of your take on quantum internet in this area?
Yeah. Sorry, I don't have a slide, but actually Rosemary's last slide was pretty good summary of how I also think about art practice and technology. So I would have been happy to keep it there. But yeah, I suppose my practice, I'm a visual artist, as you said in the intro, and I have a kind of research-based practice, and I've been a researcher in Connect for some time. And so what I'm broadly interested in is how different forms of knowledge and different types of organization kind of influence our ways and maybe our possibilities for being in the world. And so in relation to technology, I suppose I'm quite interested in how technologies produce particular cultures or ways of being, and in turn, I suppose, how different cultures, and particularly maybe research or knowledge cultures, produce different types of technology. And so in relation to the quantum internet, I guess because we're at this kind of early stage, and I suppose my practice is looking maybe at the politics of those technologies. It's kind of maybe still all to play for. So I'm interested in how can we kind of bring diverse types of knowledge into the discussion at this point, and what the outcome of bringing those types of knowledge in will be to the quantum internet.
Great, thanks, Tom. And Diego, so you're an architect by training, and which is a field that's really at that intersection between art and technology in so many ways. You want to tell us about your background and thinking on this topic?
Yes. So I studied architect, as you said. I'm an architect, as you said. It's a bridge between art and science somehow as a discipline. And I've been working in several countries, not only in Europe but also in Asia. So I learned a lot to communicate in different languages, not only culturally but also in different disciplines, different languages of different disciplines. So working in different interdisciplinary projects, and I was bringing here two images to show somehow what what I would like to show. And here it's a photo of Aarhus University where I'm working. This was in winter, and this is a digitally enhanced photo. So I not only with the camera but also then processing the image after. The objective was to try to show snow. That is a kind of very elusive aspect of an experiential situation that is very difficult to photograph snow. So I tried to show that manipulating this photo, and this manipulation was used using digital algorithms in the camera, but also then in the post-processing. And then here I wanted to show an image of a report, and my apologies that the letters are a bit blurry, but this is not a published report. So I worked on this report that was in the southwest of England, and this was a mapping exercise of different developments of an industry in architecture, to develop a database of things that were happening, and the aggregation of the different informations here of this database allowed the development of a new business in the southeast that achieves now a possible expenditure of 1 billion English pounds, UK pounds. And so I have been studying in the last weeks, and I'm presenting in Madrid a study about the art and the science collaborations in quantum in Europe. And I believe that these kind of databases can also bring new knowledges. And one of the conclusions of this study that I'm doing in quantum and art is that not only that artists bring new visualizations and new ways of showing what quantum scientists are doing, but they can also participate in the development of new discoveries because of a new way of thinking and bringing an interdisciplinary way of thinking to the process. And that's it. Then you are muted. Okay. Then you are muted.
My computer's running slow there. So Fiona, you've been kind of looking at various technologies and the historical context and bringing in internet infrastructure. Maybe you can tell us a little bit about your background and your thinking on this topic.
Thanks, Dan. Yes. So I suppose my background is in fine art and visual arts practice. And over the past decade or so, a few projects of mine have kind of touched on aspects of the internet. I suppose particularly visualizing kind of the infrastructure of it, kind of at an earlier stage. So I would have been kind of using more of a video documentary approach rather than maybe implementing the technologies as some of the other artists might. So yeah, some earlier works would have looked at kind of the dependency on kind of human maintenance of these systems and like the repair of fiber optic cables at sea, and also kind of weaving those visualizations of the system into narratives around how they're used in, say, financial trading or kind of other industries. I suppose then kind of maybe another project would have looked more locally in an Irish context at how Ireland, I suppose, since its independence has, or did for at least a phase, function as kind of a test bed for experiments in certain communication networks. I suppose due to its geographical location and its, I suppose, history having been part of, I suppose, a colonial network that was kind of existing from a telegraph kind of historical point. And then I suppose most recently and kind of a current research interest is a project that's looking at some of the imperfections and kind of I suppose, weaknesses in the classical internet as we know it in terms of security. And I suppose I'm developing a work around some of the actions that are needed every few months to maybe reinstate kind of security key kind of registrations that keep things as current as they can in terms of protecting kind of routes through, like, say, a domain name system kind of registry and that sort of thing. So that's kind of a broad overview on kind of the angle of the internet that I've been kind of focused on. So the quantum area is all kind of a new interest here. So it's kind of looking forward to seeing how the conversation develops. And the security aspect, I think, of quantum internet is something that I suppose I'm interested in terms of what it means for the existing internet as well, and if the two can coexist, and maybe what the potential for the current infrastructure to be shared is. And yeah, from an artist's point of view as well, I just kind of see what the creative processes that can implement it are. I'm not sure how much the security aspect is a priority maybe to artists, but I'm interested to see how that conversation opens up.
Great, thanks, Fiona. So maybe we could turn to Saikat, and you had a slide of a few examples of the intersection of art and the quantum internet. You want to go over that a little bit? And
Sure, I can do that. Let me share that slide back again. These are just some bullet points to jog my memory on what a few of the points actually were just discussed. So I would start with the role of art as I perceive it in quantum. And Diogo actually made some couple of very good points. The first one that Diogo just talked about was the creative expression that art might bring to the table on explaining some concepts that are extremely difficult. I mean, these are concepts that are extremely difficult to even explain to scientists and students of engineering and science and physics. The concept of superposition, that two things can be, one thing can be at two places at the same time, or two things at the same time. The concept of entanglement, that is an extension of the concept of superposition, where two bits, rather than being in one of four possible states, can be in any superposition of one of those four possible states, which means that when you make a measurement on them, when the state of these two qubits collapses, that they are correlated in a way that cannot be generated by any classical system. Then the fact that measurement, the act of looking at a quantum system, the act of measuring a quantum system immediately leads to the collapse of that in an intrinsically random way, a randomness that is not generated by a computer that knows how to generate that randomness. It is nature generating that randomness. How do you explain these things? And then Diogo also talked about how artistic skills or artistic ways of thinking could actually lead to interesting insights in research. And I particularly am a strong believer in that. I mean, one example that comes to my mind, one of my students is working on creating a game, a computer game that could be played by hopefully middle school kids, and they don't need to know any quantum. But then once a player gets better and better at playing that game, which is it's actually a quantum extension of the game of Tetris, they will find better ways of implementing a quantum circuit on a photonic measurement-based quantum computer, a problem that is hard, provably, in the language of quantum mechanics or computer science. So there are both of these kinds of ways in which art could play a role in quantum. And then the other kind, how quantum technologies can assist with art. And so this basically goes to all sorts of technological uses in art. I mean, even outside of quantum, things like, say, Apple Pencils helping artists express their art, or technology that goes as way back to vacuum tube-based amplifiers for acoustic guitars, and digital editing of music. Somebody just brought up digital enhancement of pictures, AI-generated scores that we just heard about. All of these things. So for quantum, the few kinds of unique things that they bring to the table. So one of the things, I'm a violinist. I have a bachelor's degree in Hindustani classical music. And one thing about music is that there's a lot of inherent role of improvisation. Could quantum play a role, this aspect of wave function collapse that generates randomness, but in a structured fashion? Can you create a quantum state in a way that it generates randomness that is structured, say, to stay within the confines of some rules, like the concept of raga Hindustani music or similar concepts that exist in jazz? Quantum powered AI. So, I mean, there's AI generated music, AI generated art. Rosemary talked about that. Quantum computing brings to us computational power in a sense that something that cannot be even simulated by classical digital computers. We think, we don't know, that human brains are classical machines, although there is very little that we understand about our brains. So is it possible to use quantum powered AI to generate art that is even in principle impossible to generate otherwise? We don't know. We just heard about privacy preserving or security aspects of quantum. So Fiona made a very good point about that. I didn't know how much artists would care about this, but you make a very good point that one of the things that the quantum internet particularly will enable is anybody who is connected to the quantum internet to be able to access these really powerful quantum machines on the cloud. For example, for generation of art or other purposes that is provably secure, meaning even the owners of those quantum computers will not be able to know what they use those really powerful machines to do for themselves. If there's value to that, that brings to this community, that's another possible thing. Then the one final thing I would like to say is one of the applications of shared entanglement is coordinated actions. Okay, so let's say two people want to show up in a city and meet at one location. They don't care where they meet as long as they meet at the same location. Okay, but they also want that nobody else in the world provably know that where they met. This kind of a thing can be solved by them pre-sharing entanglement. Again, something that cannot be done classically. Are there reasons for us to believe that such coordinated actions might have roles, say, in performing art forms or other forms of art? Like coordinated actions are all over the place, in rhythmic interactions of musicians, dance, and jazz music, and all over the place. So anyhow, so with those seeds, I'll stop my screen share, Dan, and give it back over to you. These are all questions. I don't have answers to them.
So maybe Rosemary, do you want to respond to Saikat? Are there some things that strike you there as interesting from an artistic perspective?
Yeah. I think immediately the idea of like how quantum computing could potentially facilitate processes or affordances that might not have been possible with other technologies, that's immediately fascinating. Like how can this change the way that we think with technology? How can this change the way that we design with technology or work with it? So that's immediately like very, very interesting and obviously unknown, like that this will remain to be seen what direction it could go in, or directions, surely. And that's very interesting. And I think something just from my background, looking at artists, working with machine learning and working with machine learning in my own practice, the challenge that I've found there, and I see could be related here, is that at least with advanced forms of visual technology, we tend to have a really hard time understanding them, like the reason for understandable AI, and artists have been quite successful, I think, in working with machine learning in such a way that it starts to be kind of domesticated, like it starts to be a little bit clearer perhaps to the public, like what is AI and what is machine learning and what are the processes that go into it, at least in like a tangible, basic sense. And I think, but I think as these systems become more and more powerful, something that's been very challenging for artists is like how do we even grapple with that? Like when things are inherently non-visual and very opaque to understanding, even for high-level computer scientists and mathematicians, then we start to, of course, artists love when things fail. Like we love the glitches and the errors because that kind of gives us more to work with. It gives a little bit more understanding of like the inner workings somehow. So I do feel like maybe that's a potential avenue for like future exploration, and might also be, it might be an area for interesting problems and interesting questions to come out of for artists as well as other researchers and maybe more broadly.
Andrew, thanks. Tom, you have thoughts on that?
Yeah, thanks, thanks, Dan and Saikat and Rosemary. Yeah, I mean, one thing that kind of struck me that I think is kind of interesting, I suppose, as I said, my kind of interest generally is how the sort of knowledge systems that we use and the cultures in which they're kind of grounded produce different technologies. And I was kind of struck by Saikat when you were talking about the difficulty in understanding quantum computing, which I must admit to having struggled with. But when you mentioned, I kind of got a grasp of it a little bit when you mentioned the difficulty in understanding things like superposition, where something is not all one thing or the other, or about entanglement, where these things are connected. And of course, when you describe them that way, it's kind of inherently understanding. But you mentioned that they're sort of the things that those things are kind of difficult to explain, I suppose you said, even to an engineer or a scientist. And I must at this point come a little bit clear that I have the superposition of having studied engineering as well as art. And so what struck me about it was that actually those things I think are quite understandable to people in various other ways, but maybe not so much in the sort of knowledge systems that we use in engineering and in science. And so one thing that interests me is what's the role of different forms of knowledge in understanding these things, and actually within a research center, which generally sort of Connect or in Arizona, generally has a huge kind of strength in knowledge such as physics and in classical computing and so on. But how can we bring other types of knowledge to actually help us understand these things? And I think art has a really kind of big role in this. One kind of example springs to mind, which I suppose is something like fiction, and where it can really kind of unlock, I suppose, a different way of thinking about these things, and in which things like a change from discrete knowledge to continuous knowledge or complexity, I think, are really quite normal and really like inherently part of being in the world. So it's interesting. That I think those, when just as you described them in language, it actually was like, oh, they make quite a lot of sense, even if they don't maybe in classical maths or classical physics or whatever.
So maybe, Saikat, before you respond to Tom, we do have a question in the Q&A that I think is perhaps a little bit related to this. So Jessica Foley asks if Saikat, you can elaborate a little bit on the relationship that you see between jazz improvisation and quantum processes. And to all the panelists, is there more than a metaphorical connection here? And what kind of needs are calling for quantum processes, both from a technological point of view and from a cultural and creative point of view, an artistic point of view?
Okay, I can take a crack at an answer to that, and anybody feel free to share your views as well. So the way I see is that there are two kinds of answer to that first question, and it does relate to the point that Tom was talking about. So the first kind is that the relationship between improvisation and quantum processes, one way to think about it is, can we create a quantum process that can generate improvisational art? Okay. And of course, there are, if you look online, you would find many examples of computer-generated jazz music. There's a whole initiative on computer-generated Hindustani classical music, where you train a computer to generate compositions of various genres within a raga, and then it would generate one. Quantum systems generate inherent randomness. So I'm not sure if that will provide more value over a classical randomness that generates the kind of music, kind of art that people are looking at. But it brings in an additional layer of power to that process. So this will basically extend the work that classical AI is doing. The other is probably a lot more futuristic, and I have no idea whether this will ever play any role, but I'll mention it anyway. So we've all heard about brain-computer interfaces, right? Where so these are actually real systems. You can read brain signals, and they are relayed to devices that carry out some actions, like robotic actions. And these have found uses in things like rehabilitation after stroke, amputations, PTSD, and all sorts of applications. But it's been always one way. The signals that come from the brain, we try to understand them, do signal processing, and use it to control other things. Is it possible to have signals flow back into our brains? And if so, can we have quantum systems that generate those signals, say, for example, using a system of entangled qubits that could create actions that are coordinated? Will that play ever any role in art? So again, these are obviously very, very speculative answers to that question. And anybody feel free to jump in, and I can go into Tom's question specifically later, Dan, if you have time.
Tom, you want to?
Yeah, I might, sorry, just to briefly on Jessica's kind of second question about what kind of is calling for these culturally and technologically. I suppose it just goes back a little bit to what I was saying, but I think classical computing really sees the world as a series of discrete, things. I suppose it's divided into kind of binary logics, and at even a kind of metaphorical relationship. I think it's a system that doesn't really capture the world. In whether quantum computing, the fact that it deals with continuous logic, can answer that question, I don't know, but I definitely think something is calling for a different model. So, sorry, yeah, thanks.
Do you have thoughts here?
So I wanted to bridge somehow one aspect that Hekat was mentioning, and also one of the questions of Jessica Foley, that is the relationship between jazz and quantum processes. And I sometimes felt when working in teams that we were developing something interesting, that there was this kind of improvisation of a jazz band, that you are picking something that the other says and building on it. And there is this flow that happens, and things happen when you are playing music and when you are making scientific discoveries. So I think it's much more than a metaphor. It's real. I feel it as real. In quantum processes, I believe that can also happen the same, both in the discovery of new insights, and I feel like there is a lot of potential in new art forms using quantum technologies. I mean, if we see the change that photography made in art, and it was a technology that is still so simple, right, compared to other technologies that we are developing. I believe that quantum technologies can also have this potential of really transforming art genres, and in music, in painting, in sculpture, and in ways that we might not even see. I think that really interesting points of the presentation and here of the questions. I don't know if I can answer a bit to Lisa. Hi, Lisa, because I know her. She's in Hong Kong. And she's speaking about the ethical aspects, and I believe there's always this socially responsible aspect to see in any kind of technological development, also in quantum technologies. And obviously, yes, we have to take care of cultural biases in any kind of scientific discovery, to develop things for good. So this should be in consideration, and I think socially responsible quantum internet is a must.
Yeah, one thing I would say to that, Diego's last point, is the Center for Quantum Networks. It has one of the research thrusts is called Societal Impacts of the Quantum Internet. And it is led by my colleague, Jane Baumbauer. She's a professor of law. And that thrust involves researchers across the US and across the world now, with expertise in economics, social behavioral sciences, technology and policy, and other disciplines that are not STEM, scientific, engineering disciplines. And they're trying to investigate exactly the kinds of things, Diego, you were talking about, and that Lisa is asking, is that, and in fact, there's a concern that quantum-powered AI or quantum-powered computational technologies, will they exacerbate the problems that exist in biases in machine learning generated decisions? Because at the end of the day, I mean, machines are what are given to them. I mean, the information that is provided, if that comes from a source of bias, will the fact that the machine does that computation, the calculation, the predictions, the recommendations in a more powerful way, will that make the problem even worse? So there are people who are really researching these topics, and the idea is that since we are at the dawn of the era of the quantum internet, I mean, it's a 10-year-long center with the objective that at the end of the 10 years, we will upgrade all the technology necessary to be able to accelerate upgrading the internet to be able to carry qubits. Should we be thinking mindfully about these societal impact questions at the outset and work together with the engineers as they design the technology itself? If we were having this discussion back in the early 70s when the ARPANET program was being executed by BBN Technologies, would we have done anything differently with the classical internet?
And certainly with the classical internet, there's notion of democratization, right, and open for everyone, and while you know, it's a mixed message how that's turned out, and so with quantum, we have this interesting thing where you have the opportunity to be able to send information that's quantum secure, so no one could possibly tap into that information. And also there's blind quantum computing approaches, right? So it seems like there's another opportunity for some perhaps democratization or ability for artists, creative ideas to be conveyed in a way that, but also it can be used for other more problematic approaches as well. I don't know what, maybe I want to go back to Rosemary on this. So you've been kind of thinking about some of these challenging social issues around technology. Do you see some pitfalls here?
Certainly, and I definitely think I feel like this, my perspective kind of resonates a lot with Fiona's on this historical part, that how she mentioned that you know, there were already problematic issues in the design of like telegraph systems, and then we've kind of, you know, used these precursor technologies that have then kind of snowballed into much powerful systems that we're really, we've proven very poor at remediating the issues that we've put in these technologies. So I feel like I would actually love to hear what Fiona has to say about like the infrastructural side of things, and how like, because that's something I look at, like how we embed these ideas in our technology, and then and then if it's part of the infrastructure, then how could we possibly, you know, take it out again?
Thanks, Fiona.
Yeah, well, that's all kind of an angle I was kind of thinking about. And I suppose one of the luxuries of, I suppose the complexity of this technology to kind of get to a point where it's kind of rolled out to a public is that in that slowness, there's time for these conversations to happen and for things to be adapted kind of in the process rather than retrospectively. And I think as well, I suppose having learned from, I suppose the template of the internet that we've experienced over the last, say, I suppose 25 odd years, kind of in it for the general public at least. I suppose that what we're envisioning isn't as blank slate as it would have been in conversations kind of prior to any permutation of an internet as such. So, sorry, I'm trying to think what the angle of Rosemary's actual question there was. Sorry. Can you remind me just of your particular angle?
Oh, yeah. I was just thinking. I feel like you addressed it, but just thinking about how do we deal with very complex systems that are then kind of have very problematic issues embedded in them, and how we tend to like make new technologies and then be like, oh, this can do so many new things, but we're actually going to use it for racism, and then like just make kind of new, you know, new forms of the same issue. Yeah, I feel like maybe that wasn't a question, but yeah, just kind of riffing on that.
I suppose just even moving on kind of, yeah, on a tangent, I suppose, a bit from that, but I guess a lot of it depends on the interfaces that we're kind of provided with for interacting with this. And I suppose there's still a bit of, I suppose, vagueness maybe about how exactly those platforms kind of will be kind of opened up to a general public. And I suppose from kind of the limited knowledge I have on kind of where research and the development of this is, I guess there's kind of hubs around the world that are all in some ways connected with what the research are, but I'm sure there's also a certain amount of protection of the progress in each of those situations. So I suppose in terms of, say, the funding that some of the larger corporations and organizations are putting into their own research, I guess how that affects what version of what they're progressing with is put to the public is kind of interest to me. And I suppose the fact that, as I was saying, artists are kind of minnows in this kind of environment in terms of maybe the kind of financial backing or the kind of priority of these systems for them. But I guess large for financial transactions in those kind of industries have a kind of a dire need, I suppose, for this before a quantum computer undoes the cryptology of what we have in existence already. So yeah, I guess.
No, that's a great point. So we're coming from the kind of hyperscale community is really driving this, and the a lot of the large governmental labs and that are often thinking about more security related issues. And so yeah, I guess maybe we can think about, so there are companies that the hyperscalers are, they run the big data centers. They are building infrastructure leading towards a sort of data center of quantum computers, right? And these quantum computers, to keep in mind that today they are built in these large cryostats. So the qubits have to be held at 4 Kelvin or below in temperature. So very extreme environments, low temperatures that requires quite a bit of resources and energy to make that work. And not to mention the expertise to build that kind of infrastructure. So further, it's kind of really amplifying this whole technology infrastructure mountain that we're climbing here, right? So, but I guess I've seen trends where there are startup companies that are working on quantum computers. So IonQ, they've been showing this picture of one of these a quantum computer sitting on a table in a lab that you could imagine kind of like a workstation computer of 20, 30 years ago, that might be in an office or lab or somewhere, and looking to make these available to everyone, and where the quantum internet would allow you to connect in there. Is maybe go back to SciCut, is that where you see the quantum internet heading? Maybe we can talk a little bit about what the infrastructure might look like for this.
Yes, so the infrastructure for the internet will the quantum upgraded internet is how I like to think about it. It will use all of the conventional fiber technology, lots of the conventional photonic technologies. In addition to that, there will be new hardware that will have to be introduced. For example, quantum memory is a big one, something that can actually hold on to a qubit, store it, process on it. Quantum computers that can convert a qubit's quantum state into a photonic state that can fly long distance, because photons are the only kind of bearer of a qubit that can go long distance. You'll have to use conventional optical fiber and conventional optical technologies, except that the requirements on them will be a lot more stringent than classical internet. And then there will be things like quantum repeaters. You cannot amplify a quantum encoded data stream using a conventional optical amplifier because it kills the quantum nature of those states. So they are much more delicate. So there are the Center for Quantum Networks, a big effort is in building that quantum repeater or router. So there will be new things that have to be brought to bear to upgrade this technology. I mean, the last question I see on chat relates to this. I mean, that functioning quantum computing seems to be ways away. I mean, I don't know if I have a good prediction for it. Dan mentioned IonQ. This is the first quantum computing company to go public. Quantum computing as a technology is progressing very, very rapidly right now across the world. If you look at the number of qubits, number of gates they can do on them, that's rapidly progressing. In fact, we are at a point where we can do computations on, say, hundreds of qubits, and that already puts us at a point where we cannot even simulate what they will do on a classical machine. And that's where you get to a point of discovery where you cannot simulate that discovery. It's a very, very interesting point to be in this technology, where it is right now, the technology. Just like think of how when classical computers got to a point, so back in the late 70s, where it could do computations that you could not do by hand, could generate things, discover things that was not possible. But when will quantum internet be a reality to this question? I don't know if I have a good answer. It could be as soon as, say, 10 to 15 years from now, we will start to see long distance connections between quantum machines that can at least send qubits at a small rate or a low data rate, where it will be something that we can get as a service, something that Comcast could bring to their homes as an additional service you could buy. That is probably still a few decades away, but it's at this point it's a wild guess.
Yeah. So thanks, SciCut. So by the way, we're having some questions coming through on the Q&A. So thanks for that. If folks have more questions, please include them. And so we have a question here. Thinking of fields in the landscape to art. So in terms of use, activity types with strong or porous boundaries, the metaphysical and quantum scientific fields and similar entities, any thoughts or responses on this? Can we, so in the landscape to art, so I don't know if Fiona or Rosemary.
I don't really have much. No, not on that.
So maybe if the person who asked that question, if you could elaborate a little bit more to connect us in with what you're thinking there. So we have a question for SciCut. Has research, in your research, have you encountered evidence of self-similarity or fractal structures in modeling simulation of quantum entangled systems and networks? If so, could this be used as explanatory art?
That's a great question. I would say the short answer is yes. So quantum machines can generate complexity that goes far beyond what classical complex systems can do. So there's a whole field called quantum chaos. Now I would give you one example from photonics. If you take two single photons, and have them interfere on a beam splitter, just impinge them on a beam splitter, what happens is that either both photons go this way or both photons go that way. But then they do so in superposition. So actually both of those two things happen. So both photons go this way and both photons go that way. You never have one photon go this way and one photon go this way. But then when you put a detector on the output is when you actually, either this detector generates 2 clicks or that detector generates 2 clicks. But that clicking process happens at the time of the measurement. It actually, both of those two things happen. And the fact of observing that collapse your wave function to one of those two possibilities. Can you describe that using artistic expression? And then when you take it beyond that, when you take, say, 3 photons in a circuit involving 6 waveguides or 6 wires that mix those photons in a network of beam splitters, then you could have 50-something possible ways in which those photons would appear in the output. And that wave function is hard to calculate even on a classical machine. So if you Google boson sampling, this is a very well-known concept on quantum supremacy, on building a machine that can do solve problems that are provably hard to do on a classical computer. That was exactly that. Can you artistically, can you come up with a ways of expressing that photon wave function that is easier to intuit, that is easier to understand by the human brain than writing those equations involving matrix permanence that describe the probabilistic nature of how those photons emerge at the output of that waveguide? So I think the answer is yes, but it's a field worth exploring.
Yeah, so I mean, to that point, so Tom, you've kind of seen artistic practices in a research center and helping to influence engineering practice. Are there some methods that we should be thinking about and using here in terms of how art can help to shape the development of a quantum internet?
Yeah, well, I mean, I suppose maybe my interest is less maybe thinking about how to kind of maybe illustrate those outputs, although I know there are certainly, I think, has come up earlier on, certainly maybe art has a way to deal with complexity that is maybe difficult in some other kind of knowledge systems. But I'd actually kind of like to jump back to a point that Rosemary made earlier on around building on these infrastructures. So if we build this kind of quantum internet on these infrastructures that are maybe already problematic, and I think one of the potentials for art is actually to interrogate existing kind of assumptions that underpin those infrastructures, are the systems we're building them on. And so I think about the existing internet and, for example, the massive energy use, and this came up, Dan, you mentioned earlier on, the massive energy use, all these data centers, and that's built not just on a kind of technical necessity, but on a kind of ideological one. So one in which, we have this requirement for constant availability. So we have things multiplied in multiple data centers because the optimization is around, say, speed or seamlessness or a sort of ability to make transactions happen quickly. And similarly, things like blockchain are built on this ideology that we can't trust each other, and maybe grounded in a particular kind of libertarian ideology. And so I suppose what might be interesting at this point in the development of the quantum internet is how art can help interrogate the assumptions that are already going into the development of the quantum internet. So what are the underpinnings? What are the kind of the base assumptions that we're bringing into this development? So questions around privacy, like the existing model of the internet and the need for all these data centers is based on this kind of value of data and this implication of security and the need to protect things because of their economic value. So maybe there are different types of internet in which data could be a sort of communal resource, or where we actually don't also require like the level of surveillance around other people's information, or we see it as belonging to them, not as a resource for the collector. So I think art has have a real role in that side of it, and that kind of, I suppose, to me precedes the question of finding out what happens at the end of it. You know.
Yeah, and so we have a question from Tyler Mills here that is related to that, right? And brings up this whole issue of these non-fungible tokens, right? So, so is there a quantum counterpart to NFTs, or might there need to be? And if quantum computing promises existing blockchain infrastructure, or compromises existing blockchain infrastructure? Maybe Saikat, you want to take that on?
I'm not an expert in blockchain, unfortunately, but I would say that quantum computing, when it gets powerful enough, will compromise the conventional or current day methods of secure communications. So the way all of our current day transactions on the internet, like when you put your credit card in or your password on the internet, most of the conventional security systems, they rely on one variant or the other of the Diffie-Hellman based key exchange protocol, whose security relies on the fact that classical computers cannot solve certain problems like the discrete log problem or factoring, for example, which we know that quantum computers, when they get big enough, will be able to compromise. On the end, and privacy preserving queries of databases. Like, for example, if you're trying to look something up on Google and they're willing to provide you that service, you're willing to pay for it even, but then you don't want them to know what you just queried on their database. Things like that. There are solutions using quantum internet, accessing a quantum database over a quantum secured link, which can be done in a way that that does not have to rely on assumptions on what the adversary's computational capabilities are. So right now, the way we solve all of these privacy preserving actions on the internet is by making assumptions, well-founded assumptions, but assumptions that certain math problems are hard to solve by an adversary on a classical computer. So that's what quantum takes away. You don't have to rely on these beliefs. Your security promises come from the laws of physics being true.
Thanks, Saikat. So Fiona, do you have a comment?
Yeah, well, I suppose just on what Saikat was kind of finishing off there on, it kind of in a way answers part of the question I was wondering about in terms of how they can coexist. But from what you're saying, I gather that they would need, I suppose we don't know when maybe quantum computing capabilities could be unleashed kind of on those systems it could undo. But the idea that a certain percentage of all activity in that vein would have to kind of have a set time to transition to the quantum system, and kind of what's left on the kind of current internet is a kind of a whole other purpose kind of thing, that it's there's like a duality in its uses across the two. And I think I asked earlier just about I suppose the idea that in the short term, the quantum network would be kind of tested and using, as you said, like the existing fiber optic cables and the system that's already there, but with kind of new hardware at each end for that particular technology. But in long term, it would be the idea that it would move to an entirely kind of quantum exclusive network. Would that be kind of what you would be thinking, or would it always share the infrastructure?
It's a good question. I'm not sure. I would say that parts of the infrastructure may be quantum exclusive, but I see it very hard to imagine that that something will be quantum exclusive at a large scale. So it would be on shared infrastructure, even within a computer. I feel that quantum computing will very likely be a co-processor, and it will only do things that it is good at doing. And so quantum computing is not going to replace classical computing. Neither is quantum networking going to replace classical networking. It will build up upon the classical technology.
Thanks, and I think that's perhaps a great way to wrap up. We're at the end of the hour. So we're looking at a quantum internet that will in principle coexist with our classical internet, and it'll be interesting to see, as we say, all the different developments that might come out of it, the future applications that would be on this quantum internet. And I think it's safe to say that we need art to really put a lens on this and help us to understand and relate to this technology that much better.